Hi, how's it going? This time we're going to do another stress problem, but this time we're going to look at shear stress. So let's have a look at the problem. All right, so here's the problem. So we have a lever that we have some forces applied by the two hands. So a 20 Newton force acting upwards and a 20 Newton force acting downwards. And we're asked to determine the shear force that's developed in the pin. So this pin here, AB, between the pin and the lever. And I've also added that we're going to determine the shear stress that's developed in this pin AB. And I've just guessed a diameter. So this is 10. So I said, let's make the pin diameter 2 and work out the stress. All right, so start by drawing a free body diagram of this lever that we're using here. We've got an external loading applied, which is a couple. So a 20 Newton force acting upwards here, equal and opposite, but parallel, separated by a distance. We've got 20 Newton force over here. So therefore, for this to be in equilibrium, we need a couple to be generated in here. The applied loading is a couple. So from sum of the moments equals 0, and using our analysis of couples, so we know the magnitude of this couple will be 20 times the distance between, which is 0.4. So 20 times 0.4. And here we have the distance between is 10 millimeters or 0.01 meters. So V times that. Do the sums and we get V is equal to 800 newtons as our shear force between the lever and the pin. So now if you want to determine the stress, let's consider a free body diagram of the shaft and take a section through the pin. So if you draw a shaft kind of in 3D, not the greatest drawing in the world, but hopefully you get the idea. So this is the pin acting through here. So I've drawn the end of the shaft and just looking at this going back in the distance. Right, so I've got something like that, and then the pin acting through. Right, so when we're calculating stresses, we need to look at the internal actions. So we generally take a cut through where we're wanting to know the force and then the stress. So here we've got our shear force acting on the pin, and you can see this is equal and opposite to the force here that's acting on the lever, and then same at the bottom. All right, and then our shear area is the area of the pin. Okay, so we just need to apply our equation or formula for shear stress. So the average shear stress is equal to the shear force, internal shear force, over the cross-sectional area. Cross-sectional area is pi d squared on 4. All right, so put all that into our equation, and working in newtons and millimeters will give us an answer in megapascals. So doing that calculation, we get a shear stress of 250 megapascals. So that's a little bit high. So yeah, you might need to make if we're actually going to design this, we might need to think about getting a larger diameter pin here. All right, so that's all for this problem. Pretty straightforward, but just goes through the process. Just goes through the process of free body diagram, internal actions, look at the area at the cross section where you're wanting to know the stress, find the internal action, and then use your stress formula. All right, simple one for now. Some more harder ones coming up later on. All right.